All right, so knowing what atoms are not, it's not all we need to do. If you look at your periodic table, you're going to see that each of your periodic tables has a little square. It has a symbol in the center. I'm going to use one of the more important ones here. Has a number at the top there. Has another one over here. At the very top of each column, of course, it's a table, so there's any table, right? Any kind of organizational table has columns and rows. Do you agree with that? Okay. So this also has columns and rows. And I'm not going to put all the numbers. You have the numbers in front of you. So there's there's just 6 here. Let me go ahead and go one more on this side and do that one, and I'll do this one too because it's kind of, and there's one in the center. So there's another couple that I'm going to put over here, and a couple that I'm going to put over here. That I'd like you to know the symbols for. Of course, there's this one that I'm going to actually go ahead and write the numbers for. I guess I should put this one here too. All right. So when we're talking about life, a lot of these elements are important. Copper's important to you functioning well. There's a number of these that lithium can be used as a drug to help you feel better. It's one of those things. Fluorine, we take it and it improves our health, the health of our teeth, right? So a lot of these elements are important to us. But there's a core of elements that that we can commonly say life is the biomolecules, these things called biomolecules. Really, the molecules of what? The molecules of life, right? These molecules, they're made of these really core elements. It's CHNOPS, chnops. Chnops. So to be clear, you have the carbon, you have the hydrogen, you have the nitrogen, you have the oxygen, you have the phosphorus, and then finally you have the sulfur. And you know what? Let me pick a different color for the phosphorus just because. In fact, if I were going to get rid of something here, I'd just get rid of these here. Right? Iron, I know, that's why you're going to forget 98% of what you don't write down. And if you're not using the 6 R's, you're going to forget even some of that, even some of the stuff that you write down. You want to remember, you want to do well on tests, you have to write it down, then you have to process it using those 6 R's. If you're not writing it down and processing it, you're going to forget. It's not your fault. It doesn't make you stupid. It's just that's the way our brains work. There is no other way around it. So, and of course this one. So this one's known as carbon. This is known as hydrogen. This one's known as nitrogen. This one's known as oxygen. This was known as phosphorus. This was known as sulfur. All right, so those are the chnops. That's what makes up chnops. But you have iron, then you have calcium, then you have sodium. What type? Let me pause. Sodium, and this is potassium. And this one over here is chlorine. So those are really, and some more important ones. Of course, there's zinc. If you look at your vitamin pills, does anybody here take vitamins at home? All right, when you get home, look at the vitamin bottle. You'll see all the elements like zinc and iron and calcium. Those are all in there. What do you think you're going to get? Your carbon, your hydrogen, your nitrogen, your oxygen, your phosphorus. That's not in the vitamin bottle. Where do you get it? Breathing for oxygen. But that oxygen is actually turned into water. You can't really use it, like metabolize it. Somebody said it over here already. Food. That's right. Food. Food like what? What kinds of foods?
Like protein.
Protein. What other kinds of foods? What are some of the other kinds of foods?
Milk.
Proteins. So milk it has protein, has some other stuff in it. What else? Protein is one. What's another major nutrient or food source? You know these. This is not something you had to read about in a book or chapter. You've heard of it. You've learned it. You're surrounded by it. You watch it on TV. You can't get away from these. At least four. At least four. Proteins and what else? I can't hear you. I can't say it.
Vegetables.
No. Continue. Continue making guesses. Come on. Proteins. Some more fundamental. More fundamental than actual part. Sugar, which is starch. Starch is a form, right? So sugar. I'm gonna change that though. I'm gonna say another word. Sugar is one of these. All right. It's called, and I know you've heard these before. What is it? Carbohydrates is right. So carbohydrates. That's the second one. Give me another one. Proteins, carbohydrates. I know you know these. Sodium is an element. That's these. These are molecules. So this is on the left-hand side of the screen here. You have your elements. These make up these. All right. So proteins, carbohydrates. What else? Make it. I know you know. I wouldn't be pushing it if I didn't know you know it. Reach into that brain of yours. Pull something out. Carbs is carbohydrates. That's what. Water is actually a good. It's one of those major ones. It's not a biomolecule though. These are all biomolecules, by the way. But water is important, so I'll put it down here. Calcium is an element. There it is. So carbohydrates, proteins, water is a molecule. It's very important. It's mostly made of water, so that's really important. But proteins, carbohydrates, come on. One more second, and then I'm going to have to say it. It's disappointing. I thought somebody would say it. F. Say what? Fats.
Yeah, what?
Who said it? Why didn't you say it before? So instead of fat, I'm going to use another word if you don't mind. It means the same thing, called lipids. Has anybody had a lipid panel done at the hospital?
No.
You can ask your parents about it. Their doctor will often do a lipid panel. What are they testing in the lipid panel? Fats, right? Different kinds of fats. You've heard of triglycerides. cholesterol. These are all lipids. These are all lipids. All right, so lipids, carbohydrates, proteins. One more. Okay, will do. DNA is one of them.
Right, what?
DNA, RNA is another one. Do you know what DNA stands for?
That
What?
word right there.
Yeah. That's right. Deoxyribose. Everybody knows what it's because it's really cool sounding. I remember being in ninth grade and learning
how to say that.
deoxyribose nucleic acid. I know I can say it. Deoxyribonucleic acid. Oh, that sounds cool.
Say it
It's like
again.
supercalifragilisticexpialidocious. It's just
I can
amazing
say
that you
that,
can say it,
but-
right? Deoxyribose. Deoxyribose.
Deoxy.
So what the category of biomolecules is called nucleic acids. All right. So that's that deoxyribonucleic acid. So deoxy is one of them. Another one of them is ribo. So an example of a lipid would be a phospholipid or cholesterol. Right? A nucleic acid example would be DNA. Another nucleic acid example would be RNA. We have a few minutes left in class. Carbohydrate example, somebody's already said it, sugar. What kinds of sugars? Well, guess what? You could put ribose, that's a sugar. Notice how they're connected, right? Ribose and deoxyribose nucleic acid. RNA is ribonucleic acid, so that ribo comes up a lot. Another carbohydrate might be starch. Somebody mentioned starch earlier, right? Starch is a form of sugar. It's a polymer of sugar. Proteins are made of amino acids. There's a ton of different proteins. That is the direction we're going towards tomorrow. We're going to be talking about different chemical bonds that help you form these, different methods of making them. Okay? And so what is it you need to go? What would be some good ideas? And you're going to have to process these. Some of you are going to have different ones that you might want to put over here on this end. Know the elements of life. That's one thing. And know the biomolecules. So if I give you a quiz tomorrow, pop quiz tomorrow, right? And you know what the quiz is going to be on. If for some reason it comes into my head that I need to give you a quiz tomorrow, I'm probably going to pick one of these two, right?
Yeah. Know the what again?
The elements of life and the biomolecules. All right? All right, so have a good one. To be clear, so that we're not, nothing's ambiguous and it's pretty straightforward. You have carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Those are the elements of life. The four biomolecules, 1, 2, 3, and 4. The four biomolecules categories that we're going to be talking about are proteins, carbohydrates, lipids, and nucleic acids. So as you go through your study guide, if you go through it tonight, you're like, I wonder what we're covering about. You can go and look at these four there. Now, there's going to be a lot of detail that you're going to be missing, so I wouldn't try to fill in the blanks. We'll be going through it the next few weeks. But these are the four things we have to figure out. What are they? Don't put anything away until class is over, please. Please. Yes.
About fatty acids.
Very good. Fatty acids would be here in lipids.
It's like a type.
A fatty acid is yeah. Focus, please. These four are key. And to be clear, each one of these has, some of these, for instance, proteins have carbon. Let me color code these. Proteins have carbon, they have nitrogen, they have oxygen, all right? They have hydrogen. They have sulfur. Interestingly, they have probably less of the oxygen and more of the carbon than they do in the nitrogen. In fact, they're made of what we call amino acids, which are focused on nitrogen. But understand that what is it that you don't see here that's here? Phosphorus. Phosphorus isn't listed there. Carbohydrates are, get this, look at carbohydrates. Carbohydrates are just C, H, and O. No nitrogen, CHO is carbohydrates. No nitrogen, no sulfur, no phosphorus. Lipids are mostly, hear me, mostly carbon and hydrogen with a little bit of oxygen. Not as much as carbohydrates. Lipids are mostly carbon and hydrogen. There's a little oxygen in a lipid, but not a lot. It's mostly carbon and hydrogen. It's a long chain of carbons we call lipids. In a second, thank you. Nucleic acids have nitrogen, carbon, oxygen, hydrogen, and guess what? Some sulfur, not a lot, some sulfur, but they also have what? Phosphorus.
So it has chnops.
Yeah, nucleic acids have the whole schnapps, except the sulfur is very little of it. There's more sulfur in a protein than would be in nucleic acids. But there you have it. Have a good one.
I did want to add a couple corrections. First of all, it's nucleic acid. So it's nucleic acid. I misspelled it in the rush to try to get things done. And then, so this is incorrectly spelled, nucleic. And the other correction I'd like to make is that lipids, sometimes there are certain lipids, specifically phospholipids, that do have phosphorus as well. But again, the key to lipids is that the main component of lipids is carbon and hydrogen. Yes, there's some oxygen, but proportionally speaking, the majority of the atoms that make up the molecule when you're talking about lipids are carbon and hydrogen. With carbohydrates, you have CHO. And in fact, you have, for every one carbon, you have 2 hydrogens and 1 oxygen. So you have the carbon and the oxygen are about equal in a carbohydrate, and there's twice as many hydrogens in a carbohydrate. Where in lipids, it's carbon and hydrogen are the 2 main components. Oxygen is not a one-to-one. You don't have as many oxygens as you have carbon. If you have as many oxygen as you have carbon, you're probably dealing with a carbohydrate, not a lipid. With proteins, you have carbon, nitrogen, oxygen, hydrogen, and sulfur. So you have, now the sulfur, it depends on the amino acid that you have, but you certainly have carbon, nitrogen, oxygen, and hydrogen. Those 4 are in abundance. In nucleic acids, again, remember, look at the spelling. In nucleic acids, it's nitrogen, carbon, oxygen, hydrogen, sulfur, and phosphorus. And they're all in abundance. And you'll know the difference between, I think DNA and RNA versus the others are going to be easy for you to determine once you see them and when we look at their structure. So how would you summarize these notes? Well, I would say that if I were going to summarize the notes, I would say biomolecules are made of only a few elements. And these elements, each biomolecule has a specific proportion of elements. So when you're looking at proteins, it's CNOHS. When you're talking carbohydrates, it's one carbon for every one oxygen, and there's double the amount of hydrogen. And lipids, it's mostly carbon and hydrogen, so you see the proportions of the elements are going to be different. So keep an eye on that, and it'll help you identify which biomolecule you're dealing with. The ultimate goal here is that you understand that each of these biomolecules are building blocks for the cell, and therefore for your tissues and your organs and all the parts that make you up. All right, hope that made sense.